Stick and leaf insects are among the most precisely camouflaged animals on Earth. They carry no venom, no claws, and no meaningful speed. Their survival depends entirely on resemblance to twigs, bark, living leaves, and dead ones. This video counts down 20 species, each with a distinct mechanism for remaining invisible in a world full of predators that are actively looking for them. Number 20. The pink-winged stick insect. This stick insect of the Philippines has two ways of protecting itself, and they work in completely opposite ways. The first is to be invisible. The second is to be impossible to ignore. Together, they form a defense that has made this insect highly effective at surviving in its environment. When the insect is resting, it does nothing. It grips a branch and holds completely still. Its body is brown and long and thin, shaped almost exactly like a dry twig. It does not fidget. It does not react to small sounds or nearby movement. It simply stays motionless for as long as it needs to. Most predators find their prey by watching for movement, so an insect that never moves is an insect that often goes unnoticed entirely. The problem comes when a predator gets close enough that staying still is no longer enough. At that point, the insect switches strategies entirely. It opens its outer wings and reveals the wings underneath, which are a bright, vivid pink. This color appears suddenly and at close range. The predator was expecting a twig. What it sees instead is a sharp burst of unexpected color directly in front of it. That sudden visual change breaks the predator's concentration and interrupts whatever it was about to do next. That brief interruption is all the insect needs. While the predator is processing what just happened, the insect lets go of the branch, falls to the ground, and closes its wings. On the forest floor, surrounded by dead leaves and brown debris, it looks like a twig again. The predator looks down and sees nothing it can identify as a target. By the time it works out what happened, the insect has already disappeared into the leaf litter. Number 19. The dead leaf mimic. This leaf insect, distributed across South and Southeast Asia, does not merely resemble a dead leaf, it replicates one in the late stages of decay. The body carries brown patches, black irregular spots resembling mold growth, and ragged wing edges that copy the torn margins of decomposing foliage. Its movement reinforces the disguise. When walking, the insect rocks its body from side to side at a slow, rhythmic pace, a direct imitation of the way a dried leaf drifts and rocks in low air movement. The motion is not that of an insect navigating a surface. It resembles an object being carried by wind. The veins visible across its flattened body's surface correspond closely to the vein structure of real dead leaves. Field observations have documented leaf-eating birds passing directly over these insects without detecting them. Number 18. The giant prickly stick insect. This stick insect of Australia is a large species, and it does not rely on invisibility alone. Its body and legs are covered in thick, hard spikes that stick outward in multiple directions. These spikes change the way the insect looks in a significant way. Instead of appearing as a smooth, soft-bodied animal, it looks like something thorny and unpleasant, the kind of plant that scratches and draws blood when touched. When the insect feels directly threatened, it does not simply freeze. It raises its front legs and holds them out in a way that makes the spikes more visible. This posture is deliberate. It positions the insect so that what the predator sees most clearly is the cluster of outward-facing spines. The overall shape, at that angle, looks much more like a section of thorny vegetation than like an insect. For a predator that has already been hurt by thorns before, that image is a familiar warning. Many will turn away rather than risk the same experience again. The spikes themselves do not need to injure anything to be effective. Their job is not to fight back. It is to remind the predator of a previous experience and trigger the same avoidance response that experience created. The insect wins not by being dangerous, but by looking like something the predator has already learned to leave alone. Number 17. The bark-colored stick insect. This stocky Australian species does not hide among leaves. It rests directly on tree trunks, pressed flat against the bark surface in full daylight. Its body is gray-brown with an uneven texture, not the smooth profile of a twig, but the rough, irregular surface of cracked and weathered bark. A notable feature of this species is local adaptation. Populations living on dark-barked trees are measurably darker than those on pale-barked trees. The coloration is not a fixed species-wide trait, it is matched to the specific bark of the insect's home tree. The legs are flattened and spread wide against the surface, nearly eliminating the shadow cast by the body. Shadow is a primary visual cue that reveals the presence of a three-dimensional object on a flat surface. By pressing the body down and extending the limbs flat, the insect reduces this cue to near zero. Number 16. The spiny stick insect. This species, found across parts of Africa and Asia, carries thorn-like spines along its legs and body sides. It lives among thorny shrubs, and the spines on its body match the plant's thorns closely enough that the two are difficult to distinguish at close range. The spines on the insect's body are not, in most cases, sharp enough to physically injure a predator. Their function is associative rather than mechanical. Birds and lizards that have encountered thorny plants and received minor injuries from doing so develop avoidance responses to anything with a similar visual profile. The insect borrows that learned aversion without possessing genuine defensive capability. Number 15. The jungle nymph. Among the heaviest leaf insects in the world, the female of this Malaysian rainforest species can reach the weight of a small mouse. The body is wide, flat, and bordered by thick ridged plates along the sides and back. From above, the insect resembles not a single leaf but several overlapping ones. The plates fan outward like layered foliage. The coloration shifts from fresh green at the center through yellow-green to brown at the margins, matching the natural color gradient visible across real plant clusters. When threatened, the insect releases a chemical compound from glands located on the body surface. The odor replicates the scent of the plants it inhabits. A predator that closes within smelling range receives a plant signal, not an insect signal. Number 14. The twig mimic. One of the most common stick insects in the world, this species ranges from the southern United States through Canada and is regularly present in parks, gardens, and suburban woodlands. It is slender, long-legged, and a uniform medium brown, consistent with the color of a dried twig in late autumn. It carries no spines, no leaf-like projections, and no unusual patterning. The survival mechanism of note here is not the insect itself, but its eggs. Each egg carries a small, fatty attachment called a capitulum, structurally similar to the eleosome found on ant eggs. Ants collect these eggs and transport them underground to their nests, treating them as food stores. Underground, the eggs remain protected from temperature extremes, predation, and moisture loss. When the eggs hatch, the juvenile insects climb out of the ant tunnels and disperse. The ants receive no benefit from the transaction. Number 13. The two-striped walking stick. This stick insect of North America is known for having one of the most effective defenses in the group. Most stick insects depend almost entirely on camouflage, but this species can also release a defensive chemical. Specialized glands located behind its head produce the spray. When the insect is disturbed, it directs this chemical toward the threat. Contact with the spray can cause severe irritation and may lead to temporary blindness if it reaches the eyes. Birds, reptiles, and small mammals typically avoid the insect after a single encounter. Even with this defense, the two-striped walking stick continues to rely primarily on camouflage. It remains motionless on branches, where its long brown body closely resembles a thin twig. The combination of effective camouflage and a chemical defense makes it one of the most well-protected stick insects in North America. Number 12. The black jungle stick insect. Most stick and leaf insects match greens and browns. This high-altitude rainforest species is nearly entirely black, with faint gray mottling. It lives on dark, mossy rock surfaces, blackened tree trunks, and shaded forest floors, environments where green or brown coloration would be conspicuous rather than concealing. Unlike most of its relatives, this species is active during daylight hours. It moves through shadowed zones, the areas beneath overhanging branches or dense canopy, where the existing darkness of its surroundings deepens the concealment effect. The insect positions itself in the shadow cast by overhead vegetation, using the environmental shadow to supplement its body coloration. Number 11. The winged stick insect. This species, distributed across parts of Asia and the Pacific, appears unremarkable at rest, brown, mottled, motionless, consistent with its stick-like surroundings. Concealed beneath its dull outer wings are brightly colored inner wings, vivid red, electric blue, or orange, varying by population. When a predator closes in and the camouflage is no longer sufficient, the insect opens these inner wings for 1 to 2 seconds, producing a sudden burst of color. The predator, neurologically tuned to track moving bright stimuli, fixes its attention on the flash. The insect then closes its wings and becomes motionless again. The predator is now searching for a brightly colored moving object. What remains visible is a brown stick. The insect has not traveled far. It is in the same location, but the predator's search image has been replaced by a stimulus that no longer exists. Number 10. The lichen mimic stick insect. Rather than mimicking a leaf or twig, this species replicates lichen, the patchy gray-green growth found on tree bark and rock surfaces. Lichen is largely ignored by most predators. It is dry, tough, and nutritionally negligible. Animals have little learned or instinctive incentive to examine it. The insect has a flattened, irregular body profile with gray-green coloration and a rough, uneven surface texture. It spreads its legs wide and presses against bark, filling the available surface area in the way that actual lichen growth occupies gaps between bark ridges. Its coloring is not uniform. It is distributed in random patches that match the irregular, non-geometric pattern of real lichen colonies. Number 9. The stick insect that reproduces without males. Across numerous stick insect species found in tropical Asia and Australia, populations consist almost entirely of females. In some species, confirmed male sightings have not been recorded in decades. Females reproduce through parthenogenesis, producing viable eggs without fertilization. Those eggs hatch into females, which in turn lay more eggs. Populations continue across generations with no male contribution to reproduction. The practical advantages are significant. A population does not require a minimum number of individuals of two sexes to sustain itself. A single female introduced into a suitable habitat is sufficient to establish a new population. There is no energy expenditure on mate finding or courtship. And if a population is reduced to a very small number by habitat loss, predation, or isolation, it can recover from a single surviving individual. Number 8. The stick insect with chemical spray defense. This Southeast Asian rainforest species resembles an ordinary brown or green twig at rest. Behind its head, however, it carries a pair of glands capable of producing and projecting a chemical spray up to approximately 40 centimeters, roughly 16 inches, with directional accuracy. The spray contains compounds that cause intense burning sensations on skin and, more critically, on the mucous membranes of the eyes and nose. Predators struck by the spray experience immediate irritation and vision disruption, and typically redirect their attention toward removing the substance from their face. This provides the insect with sufficient time to escape. The insect is capable of rotating its head to aim the spray toward the source of the threat, regardless of the angle of approach. Number 7. The water-adapted stick insect. This species, found in parts of Asia and Australia, lives in vegetation along the margins of slow-moving streams and shallow waterways. Its appearance is consistent with others of its group, a slender, brown-gray, twig-like body, motionless during the day. When threatened by a land-based predator, the insect drops directly into the water. It is capable of moving across the water surface using the same surface tension mechanics as water striders, and can also submerge and walk along the bottom of shallow streams. Land-based predators, lizards, and ground foraging birds rarely pursue prey into water. Aquatic predators such as fish are not searching for an object with the visual profile of a broken twig. The insect occupies a gap between two predator search categories. Number 6. The pale stick insect. Found in certain isolated island habitats, this species has evolved near complete depigmentation. Its body is white to translucent with only faint patterning. It inhabits bleach-dried grasses and dead reeds in open areas, where its pale body becomes indistinguishable from the surrounding material. The translucency of its body wall is sufficient to render internal structures partially visible. The outlines of the digestive system and developing wing buds are observable through the body's surface. The same translucency affects how the body interacts with direct sunlight. Rather than casting a sharp, distinct shadow, the body allows light to pass through partially, producing only a vague, indistinct shadow on bright days. The reduction in shadow clarity makes the insect harder to detect even under direct illumination. Number 5. The flat-bodied leaf insect. Isolated from the rest of the world's fauna for millions of years, Madagascar's wildlife has followed evolutionary paths not found elsewhere. This leaf insect exemplifies that divergence. Its body is extraordinarily flat, not simply leaf-shaped in profile, but compressed to a degree that when viewed from the side, the thickness approximates that of a piece of cardboard. This degree of flatness enables a specific defensive behavior. When wind moves through a bush, real leaves rotate edge-on to the airflow. This insect does the same, orienting its body edge-on to the approach angle of a potential predator, reducing its visible cross-section to near zero. It rests at an angle matching the natural droop of a leaf hanging from its stem, rather than lying flat against a branch, the way most insects position themselves. The posture is not random, it replicates the geometry of the surrounding vegetation. Number 4. The stick insect that mimics a scorpion. Found in parts of Southeast Asia, this slender species appears as an unremarkable twig under normal conditions. At the tail end, the abdomen terminates in a slightly curved, pointed tip. When threatened, the insect curls this tip upward and holds it raised over its back, directly replicating the defensive posture of a scorpion preparing to sting. The insect has no stinger. It is incapable of delivering a sting of any kind. The predators it most commonly encounters, birds and small lizards, have innate or learned aversion responses to the raised tail posture of scorpions. When the insect adopts this pose, many predators pause or withdraw. The moment of hesitation is sufficient for the insect to drop from its perch and fall into ground cover below. Number 3. The grass mimic stick insect. Unlike the majority of stick and leaf insects which inhabit forest environments, this East African species lives in open savanna grassland terrain with high predator density and minimal structural cover. Its body is the pale golden yellow of dry savanna grass, and it holds its body at the slight diagonal angle of a grass stalk bending under its own weight. Among tall grass stems, the insect's profile is visually indistinguishable from its surroundings. The distinguishing feature of this species is its response to wind. On open grassland, gusts move through the grass in waves, causing widespread simultaneous movement across a large area. The insect does not wait for physical contact to begin swaying. It responds to the air pressure and sound cues that precede visible grass movement. It is in motion before the surrounding grass moves, and in synchrony with it once the gust arrives. When it needs to walk, it does so only during active wind gusts, using the general motion of the grass as cover for its own displacement. Number 2. The stick insect with limb regeneration. Several stick insect species from Southeast Asia and Central America possess the capacity to fully regenerate lost limbs. This includes legs, antennae, and partial abdominal sections, achieved through successive molting cycles. When seized by a predator, these insects can voluntarily sever a limb at a specialized weak joint, a process called autotomy. The detached leg continues to move for several minutes due to residual nerve activity, drawing the predator's attention while the insect escapes. The lost limb is not permanently absent. Over the following weeks, successive molts produce a regenerating structure that grows progressively closer to a full limb. In young insects, regeneration is faster and more complete than in adults. Juvenile individuals that lose 3 legs can regenerate all 3 before reaching adulthood. Number 1. The wandering leaf insect. The wandering leaf insect, distributed from India through Sri Lanka, Malaysia, and Indonesia, is cited by numerous researchers as the most convincingly camouflaged animal ever documented. Fossil evidence shows the species maintained a leaf-like form more than 50 million years ago. In the intervening period, the disguise has continued to develop. The body shape is a rounded oval with a slightly pointed tip, curved gently to replicate the way a real leaf bends under humidity and heat. The coloration ranges from bright lime green to deep forest green, with natural variation between individuals, so a group of them on the same plant replicates the mixed light and dark leaf tones of real foliage. The ridges running across the body surface replicate the vein structure of the specific plant species the insect inhabits. Populations on different plant species carry slightly different vein patterns corresponding to their local flora. The body margins carry irregular bumps and indentations consistent with insect damage on real leaves. The edges are slightly wavy, matching the natural growth variation seen in real foliage. The legs are flattened into leaf-like shapes, so that even when the legs are visible, they register as additional small leaves rather than appendages. When the insect moves, it rocks its body slowly from side to side, replicating the motion of a leaf in a light breeze. Movement is never fast and never linear. When females are ready to lay eggs, they project the eggs away from the body with a snapping motion, distributing them across the forest floor at distances of several feet. The eggs land in the leaf litter, where they are visually consistent with plant seeds. Each egg carries a small hard cap at one end that replicates the structure of a seed. The eggs remain among the debris for months before hatching. The disguise begins before birth and continues without interruption through the insect's entire life. These insects are present in forests, grasslands, and island habitats across much of the world, and are largely invisible to the people walking among them. What do you think about this list? Let me know in the comments section, and do like the video and subscribe.